Hello and welcome to this edition of Coffee Break Conservation, where today I'm going to be talking about the corrosion of metalwork in old buildings. Please do like and subscribe our YouTube channel, and then you'll be kept up to date with everything that we're doing. And you can also find out about webinars and other in-person training days that we provide on our website, cbcstudies.com. This particular subject for coffee break conservation will also become a full hour webinar, which we'll do in the coming months, and you can find that on our website. So when people generally talk about metalwork and corrosion of metals in buildings, the first thing is to often think about cavity wall tie failure, where ungalvanized plain steel wall ties, typically from the early mid part of the 20th century, corrode and lead to cavity wall tie failure. But for this coffee break conservation video, I want to show you some other examples of metalwork corrosion, which you may not have seen or may not immediately think about. So here we see a staircase, a fire escape staircase it is actually, coming out of the back of a building and created with sectional metal parts which have fractured due to corrosion of the metals. And it's this corrosion, this rusting and gradual deterioration of the metalwork which ultimately leads to its failure. And it's a very common occurrence, actually. Even if you've not had much experience of it, it is actually a very common occurrence, and it's always the same when you get ungalvanized metals in the presence of moisture, which can often just be poor painting or exposed to saline environments such as near the seaside, and then that rusting then leads to ultimate failure. Here's another staircase where we can quite clearly see the advanced corrosion on these fabricated metal parts of the staircase. Now, it's a natural process. Steel and iron is going to revert itself back to its raw state when it's exposed to oxygen and moisture, and that then leads to the corrosion. It's simply the metal doing what it was always intended to do. So therefore, from a designer point of view, or an inspection from a surveyor or structural engineer, we need to be mindful of this natural state that the metal wants to put itself into, so that when doing our inspection, we can look for the symptoms and signs, which sometimes might not be as obvious as this staircase. Sometimes it might be concealed under paintwork. So you need to look for those signs in order to fully understand what's going on with the metals. And here we see a close-up of the underside of a corroded metal beam leading onto a column, which in this case has been riveted, and the corrosion is fully evident. And in this particular case, the metalwork had suffered from leaks from above, which had been persistently dripping down onto the metals over decades. Perhaps a less common sight, which you may not have seen, is metals which are embedded within cast products. In this case, it's faience, but you'll also see this embedded into terracotta. And these balustrades are, in this case, faience, molded into three parts, and within the central core of those three parts, to tie them together, is a iron bar. And you can see that on the right-hand picture. The iron bar has got damaged through decades of moisture penetration, which has then caused the bar to rust. And it's that expansion of the rust which has ultimately caused the balustrade to fracture. And in the case of the right-hand one, it is actually disintegrated completely. This is something on these images which some younger surveyors will often refer to as Regent Street disease. That terminology, incidentally, arose from the early part of the 1800s when Regent Street was being constructed largely of metal frame buildings, which then are faced in stone and brickwork, or in this case, faience, without any adequate protection of the steelwork, which then expands and causes these vertical cracks, as you can see here. In the image on the left-hand side, that large vertical crack is directly caused by expansion of a steel column behind the faience, and in the right-hand image, you can see where we've exposed part of the internal parts of the building to reveal the corrosion on that post, which, as you can see, has got no degree of protection in terms of allowing it to expand or indeed any form of movement. So it is corroded, it is then pushed the outer part of the facade away, which has then led to the vertical cracks. And here we see a close-up, and if you look very closely at the central part of this image, we can see how the rolled steel has started to delaminate. Rolled steel is not unlike how a baker makes puff pastry, where it's very, very fine layers which are rolled and ultimately then cooked to become a cake product. Well, in this case, it's exactly the same thing, except it's metals. And as the corrosion takes hold, it eventually will separate out the rolling process of that steelwork, and then we start to see the whole thing delaminate. And here's a close-up of me holding a piece of that. But when it gets so bad, it will actually completely fracture and then be able to be picked away by hand. And here we can very clearly see the layers of the rolled steel joist, which have completely delaminated, thus weakened its structural integrity to the point where it's no longer capable of performance in the building. Here's a different example of the same thing. This is a brick building, but it is not structural brickwork. That brick is simply a facade. The structural integrity of the building is taken by a steel frame behind the brickwork, and as we can see here, it's got a vertical crack, which is always the first sign of a frame and corrosion, so do be on the lookout for that. Perhaps more commonly seen is the corrosion of steel-framed windows. Sometimes they're steel, sometimes they could be other metals. Iron is another common metal in use, but the appearance is, regardless of the architectural appearance, the appearance of the corrosion is always the same. And we can see here how the rusting single glaze frames have started to get advanced corrosion. When it gets to this bad, these windows are salvageable. I mean, I know probably a lot of people would choose to take them out and replace them, but actually they can be saved with careful conservation skills. And it is definitely true to say that we have heritage skill shortages of many trades in this country, and metalwork is one of those trades that is suffering from a skill shortage. But nevertheless, it is still possible, if you put the effort into trying to find someone to be able to conserve these windows, it will be possible to do that. These images show you some advanced corrosion on the left-hand image. Here we see how the metal frame is fixed into the concrete framework of its surround, and rusting of steel reinforcement is something we'll cover in the full hour webinar. But it's the same process where unprotected or inadequately protected structural steelwork reinforcement will then expand and cause the outer concrete to delaminate itself from the building, then lead into exposure. And of course, then that advances the whole corrosion process. And in the right-hand image, we see a lower part of the window frame, which has very severely rusted, and that will now need very careful conservation. But as I say, it is possible to do this. Metals can be easily conserved and welded into place and then produced to a state where they can be reused once again. It's not always necessary to replace these things. So there we go, a quick run through some examples of the corrosion of metalwork in older buildings. You see here on the screen our social media channels where you can find what we're doing. And as I say, please do check out the website cbcstudies.com for everything that we've got coming up in terms of more coffee break conservation videos, webinars, and in-person training days. So hope that was interesting, and we'll see you again. Thank you.